There are two general categories of telephone systems: public and a private. In most cases, the public system is referred to as PSTN or POT, plain old telephone system. Major components of PSTN are local exchange, which is analogs. Local exchange include everything from the customer location to the central office. This service includes the cable plants and the cable fault at the central office. As you can see this in the diagram, this telephone represent this picture represent the phone located in your house, and this is another DTMF phone represent phone in another house. Notice that from point A to the central office, this is what is called local exchange. Most connections from the CO to the subscriber are analogs. However, inter-office switching or connection between central office to central office networks are built on the fiber optic lines in a ring structure. And calls are passed from CO to CO through switches that are connected via trunk unit. These switches at the central office and the trunk unit use SS7 or System Signaling 7 in order to discover which network should be based on the subscriber long distance provider. The next slide shows you the diagrams of the different CO. For example, this is one CO, another CO, and another CO. As we mentioned earlier, inter-office switching between CO to CO network are built on a fiber optic line in a ring structures here. So you have a trunk unit here, and then you have the switches here. MTSO, in case you need to call telephone, mobile phone, this is called mobile telephone switching office. Okay, so all of the CO is connected together in a fiber line ring format. Private or local system organizations usually implement a private branch exchange or PBX for their system. It can be hardware based and software based. In the lab that we do in class is a software based IP PBX Brikiki. We also have another hardware based, which is called Centrec. The company usually land the device to an organization, and then the organization will the device will be put in the organization clients or companies. Okay, the connection point from PBX to PSTN is called trunk, and the trunk are either analog foreign exchange system. The trunk are either analog lines or digital using T1 or ISDN. The FXO and FXS are the name of the port used in analog phone lines. FXS is a foreign exchange subscriber interface, is the port that actually deliver the analog line to the subscriber. In other words, it is the plug on the wall that deliver the dial tone, battery, and ring voltage. Here is the example from the phone company to the organization here. This is called the FXS. The FXO is a foreign exchange office, is an interface. Foreign exchange office interface is the port that receive, remember the keyword here, receive the analog line. It is the plug on the phone or machine, or the plug on your analog system. It delivers an on hook and off hook indication. If you see from here, your phone that connected to the jack wall. Here is called FXO. Without the PBX system, a phone is connected directly to FXO port provided by the telephone company. Let me see here. Okay, a single inbound or two-way line can usually support multiple actual internal phones. This support is possible because users are not on their phone at all time. For example, if an organization has 1,000 users and only 125 users are using line at any given time, and they may further determine that a peak volume would be 400 active connections, thus you only need 400 trunk. As a result, the organization needs a bandwidth to support 400 concurrent calls as opposed to 1,000 concurrent calls. The reason we need to understand this so we can assess how much bandwidth that the organization needs. Voice transmission. In order to transmit voice across PSTN, there must be method for setting up calls, routing calls, and managing calls. These are called signaling. There are two signaling methods, the in-band signaling. The in-band signaling, which is the local loop, is using the limited bandwidth in the channel. That means this is the connection between the subscriber and the CO office. Digital PSTN use SS7, which is called also outbound signaling. It sends the signal on one channel and route to another. This is usually digital and a package based and is used from CO to CO. The previous one is an analog. Okay, how the call setup works. How the call setup works, where is it here? How the call setup work here, let me see here. How the call setup works. Okay, let's say that we're gonna make a phone call. The switch gonna send a dial tone and the switch will analyze the number. This is called SSP. SSP is signal switching point, are responsible for the communication between the CO and the SS7 networks. From switch is gonna connect to STP, which is signal transfer point, are the routers that allow the SSP to communicate with each other. So the switch connect to the STP and the STP will connect to the SCP. What is SCP? SCP is a signal control point. This is the database of call processing features. So before you understand these tables, you need to understand the terminologies of SSP, which is responsible for communication between COs and SS7, and the signal transfer point is actually the routers that allow SSP to communicate with each other. The signal control point is the databases of call processing feature like call waiting, custom ring, call forwarding, and so on. Coming back to the previous slide, STP connect to SCP, and then the SPC and the signal control point will look up for services, whether they have a custom ring, three-way calling, call forwarding. Then from here, the STP will determine the route. So the STP, that actually a device that connects of the telephones. Okay, when the party leave the receiver, then the switch connect to the circuit. The whole process, this is the first two one is called signal switching point here, and then starting from the STP to SCP, this is called the SS7, which is the signaling system signaling 7 here from the STP and the SCP.